Hello everyone, my name is Anurag Khare and today we are going to discuss acceleration in circular motion, right? This topic is generally of the great difficulty for most of the students. So let us try to understand this, okay? So we already know that circular motion can be of two types. One is uniform circular motion and one is non-uniform circular motion. Okay. In uniform circular motion, we already know that speed is constant. The speed of the particle which is performing circular motion will be constant. And in case of non-uniform circular motion, the speed is not constant. Okay. In non-uniform circular motion, the speed of the particle is keep on changing, right? But here I am talking about speed, not velocity. Velocity in both the case of circular motion, even velocity in case of circular motion is never constant. It is keep on changing. So velocity will always be changing. Okay. What happen in uniform circular motion? In uniform circular motion, though speed is constant, but direction of velocities keep on changing. So that's why we say that velocity is changing even in uniform circular motion as well as in non-uniform circular motion. Okay. So we will see the acceleration in case of both non-uniform circular motion as well as in uniform circular motion, and we will see two method of finding out the acceleration. One method is, we can say, geometrical method, and another method will be vector method. Okay. So first we will see uniform circular motion. Uniform circular motion, that is acceleration in uniform circular motion. Okay. So to find out this, let us try to draw a circle, and here the particle is over here, and the speed of particle, we can say that it is equal to v, and the radius is r, right? So in some time dt, this velocity vector, this will be, the particle will be rotated by a very small angle d theta. Okay, by a very small angle d theta, right? Now the velocity vector will be in this direction, right? Though this angle looks like it's a big angle, but we are considering very small angle. Okay. Now what is acceleration? We already know that acceleration is equal to dv by dt. dv by dt, right? What is dv? dv is nothing, it is just change in velocity in a very small time dt, right? So dv is what? dv is change in velocity in very small time dt. Now let us try to identify what is the value of dv by geometrical method. Okay. So we know one concept, that vectors can be shifted parallelly in the space. As you can clearly see that at this point, this is the initial vector and this will be the final vector, final velocity vector, right? So what we have to do here, we have to find out final velocity minus initial velocity, because we need to determine dv. dv is what? Change in velocity. Change in velocity will be equal to what? Final velocity minus initial velocity. So let us try to see this. Suppose this is initial velocity vector, and since the r vector, radius vector, is rotated by a small angle d theta, so we can also say that velocity vector will also be rotated by a small angle d theta. So this will be the final velocity vector. Okay. This will be the final velocity vector, and this angle is d theta. This angle is d theta, right? The magnitude of this is v, and magnitude of this is also equal to v, right? But this is what? This is final velocity vector and this is initial velocity vector, right? Now what will be the change in velocity? So change in velocity is nothing, it is just final minus initial. So what we can say here, dv vector is nothing, it is just final velocity vector minus of initial velocity vector. So let us try to see what will be the value, what will be dv in this diagram. So what is dv here? Final velocity vector minus initial velocity vector. So this will be the dv vector. Okay, this is dv vector. Understood? Right? And if we want to find out what is the magnitude of acceleration, so the length of this dv vector will be the magnitude of acceleration. So here we can apply the formula for subtraction of vectors. So what will be the subtraction of vectors? What will be the magnitude of dv? The mod of dv, we can say that a square plus b square minus 2ab cos theta. That formula we are going to use, whole under root. So this is equals to v square plus v square minus of 2 into v into cos of d theta and whole under root. What will be the value of this? This value we can say that we can take it out as common. This value will be 2 1 minus of cos theta whole under root, right? And this value we can say that it is v into t into this 1 minus cos theta, we know that it is equal to 2 sin square theta by 2. So this is not theta, this is d theta by, this is d theta. Okay, so this value will be equal to 4 sin square into d theta divided by 2 whole under root, and this value will be equal to 2v into sine of d theta by 2. As we already know that this d theta is very small. So if d theta is very small, d theta is small, in that case sine of d theta by 2 will be approximately equal to d theta by 2. Okay, is this clear? So this value, the magnitude of dv vector will be equal to what? 2 into v into d theta by 2. 2 and 2 will get cancelled, so this value will be equal to v into d theta. Right, now we need to find out what is d theta. Since the particle is moving with the velocity v, so we can also say that particle is also rotating with angular velocity, that is constant angular velocity omega, right? And we already know that omega will be equal to, omega can be written as d theta by dt, right? So d theta will be equal to omega into dt, omega into dt, right? So we can substitute the value of d theta here. So what will be the value of dv? The value of dv is equal to v into omega into dt, and dv by dt this whole magnitude will be equal to v into omega, right? Is this clear? Okay, now what is this dv by dt? dv by dt is nothing, it is just acceleration, right? dv by dt is nothing, it is just acceleration. We will see what will be the, what is the name of this acceleration, we will see this. Okay, so dv by dt is nothing, it is just acceleration. Now since acceleration is a vector quantity, right? Acceleration is a vector quantity, and any vector quantity will have magnitude as well as direction. So here we have calculated the magnitude. Now let us try to see what will be the direction of acceleration. Okay. So to find out the direction of acceleration, let us see. Suppose this was the initial velocity vector and this will be the final velocity vector, right? This will be the final velocity vector. And this angle is very small angle. We can say that if this angle is d theta, right? D theta. So this velocity vector will be equal to dv, right? This velocity vector will be equal to dv. Okay. Now since d theta is very small, we know that d theta is very small. So this was initial velocity vector and this is final velocity vector, right? So since d theta is very small, so we can say that these two lines will be approximately parallel. Okay, which line I am talking about? This line and this line. Okay, these two lines will be approximately parallel. Okay, since d theta is very small, so final velocity vector and initial velocity vector, they are almost parallel to each other. Okay, so if they are almost parallel to each other, then we can say that what will be this angle? This angle is approximately equal to 90 degree and this angle is also approximately equal to 90 degree, right? So that means what is the direction of dv? The direction of dv, we can say that if this was the initial velocity vector, the direction of dv vector will be perpendicular to the initial velocity vector. Okay, this will be the direction of dv. Okay, and we know that acceleration is nothing, it is just rate of change of velocity. So direction of acceleration will be towards the direction of change in velocity. Okay, so the direction of change in velocity will be something like this. So this will be the direction of acceleration. Understood? Is this clear? Right? So this was initial velocity vector and this is the direction of acceleration. Now let us try to see where this acceleration is pointing in the circle. Okay. Now, so suppose in this circle the particle was moving. So here the velocity vector at this point is in this direction, right? The velocity vector is in this direction, right? What is the direction of acceleration? The direction of acceleration is making an angle of 90 degree with the initial velocity vector or with the velocity vector. So at this point the direction of acceleration will be towards the center. So this will be the direction of acceleration. Okay, this will be the direction of acceleration. Understood? So this acceleration is towards the center. That's why this acceleration is called a centripetal acceleration. Okay, so that's why we can name this acceleration as centripetal acceleration. Acceleration, or sometimes it is also called as radial acceleration. Radial acceleration. And in which direction this radial acceleration is pointing? The radial acceleration is pointing towards the center of the circle. Okay, the radial acceleration is pointing towards the center of the circle, right? So if we can say it like this, see, this is a circle. If anyone will ask you what is the radius vector when particle is over here will be something like this in this direction, right? Radius vector will be something like this in this direction. So if I will say what is the direction of r cap, this will be the direction of r cap, right? If this is the direction of r cap, then centripetal acceleration is pointing towards the negative of r cap, right? So what we can say here, this centripetal acceleration, if I want to write it in a vector form, the centripetal acceleration will be equal to v square by or v into omega. So v into omega, right? V into omega, and the direction is towards the minus r cap. So we can say that this is minus of r cap. Is this clear? This is how we can write the centripetal acceleration. Okay. Now this magnitude, we already know that v is equals to omega r. If a particle is moving in a circle, at any moment v can be written as omega into r, right. If we know that v is equals to omega into r, so we can say different form of centripetal acceleration can be written as v into omega minus of r cap. This can also be written as, if omega can be replaced by v by r, then what will happen? This formula will be equal to v square by r, and the direction is also minus r cap, and the same thing can also be written as omega square into r, and the direction is minus r cap. Is this clear? So these are the formulas that we can use. So this is basically what? Centripetal acceleration. Okay. So centripetal acceleration, when a particle is moving in a circle, then the direction of centripetal acceleration will be towards the center. This AC value is nothing, it is just equal to v square divided by r, where r is the radius of the circle, right. So I hope this centripetal acceleration in case of uniform circular motion is clear. Now we will try to see acceleration in case of non-uniform circular motion. Okay. Non-uniform circular motion. Now we will try to see acceleration in case of non-uniform circular motion. Let us see. So what happened here? If a particle is moving in the circle, okay, the particle is moving in the circle, the speed is also changing, right. If the speed will also change, right, if the speed will also change, then it is called as non-uniform circular motion, right. But since we can assume that this particle in a very small time dt, this particle is moved by a very small distance, right, by a very small distance. So we can say that the speed of the particle at point A and at point B is approximately same. Basically speed, we can say that it is same, approximately same, not much difference. Okay. So we can talk about the centripetal acceleration. The centripetal acceleration at this instant will be towards the center, and it will be equal to, centripetal acceleration will be equal to v square divided by r, right. But there will be some tangential acceleration also. Okay. So centripetal acceleration will be what? V square divided by r, right. At any instant, if the velocity of the particle is v, so at that instant the centripetal acceleration will be equal to v square by r. Okay. Now what will be the tangential acceleration? So see, so at this moment when the particle is moving, its speed is also changing, right. When a particle is moving, particle was moving something like this, right. If its speed is also changing, so if the speed will also change, then we can say that acceleration will be along the line of velocity, right. If the speed is increasing, then acceleration will be positive. If the speed is decreasing, then acceleration will be negative. Okay. So if the speed will increase, then acceleration will be in upward direction, and when the speed will decrease, then acceleration will be in downward direction. Okay. In this case, right, what you can call this acceleration? This acceleration, we can say that it is tangential acceleration. Tangential acceleration, right. So what will be the value of tangential acceleration? The value of tangential acceleration will be equal to dv divided by dt. Is this clear? So there are two types of acceleration. One is centripetal acceleration or radial acceleration. This is radial or centripetal acceleration, right? This one is radial or centripetal acceleration, and this is tangential acceleration, right? Now let us try to see this in both the acceleration together in one diagram. Suppose this is the case, and we are trying to find out both the acceleration, that is centripetal acceleration as well as radial acceleration. So this is what? This is tangential acceleration. This we can say that it is at, and what will be the value of this? This is, we can say that it is centripetal acceleration. Okay. Now if I want to find out total acceleration, what will be the total acceleration? See, tangential acceleration and centripetal acceleration, we can say that are two components of acceleration, are two components of total acceleration. So we can find out the value of total acceleration by doing parallelogram law of vector addition. Okay. So how to find out total acceleration? The total acceleration, we can say that we can complete the parallelogram. So this is the complete parallelogram, right? And the total acceleration will be something like this. This we can say that it is total acceleration. Okay, this will be the total acceleration, right? A net. Okay, so what we can write here? A net vector will be equal to at vector plus ac vector. Okay, at vector plus ac vector, right? And what will be the magnitude of net acceleration? The magnitude of net acceleration will be equal to at square plus ac square whole under root. This will be the magnitude of net acceleration, right? We can substitute its values. So a net, this value will be equal to at is dv by dt, this whole square, plus ac is v square by r, this whole square and whole under root. So this will be the value of net acceleration. Okay, is this clear? We can also determine one more thing. Which one? We can also determine this angle also. So this angle is, we can say that it is phi. Okay, so we can find out the value of tan phi. What is the value of tan phi? Tan phi is nothing, it is just at. You can see that it is at divided by ac. At divided by ac, or at is equals to dv by dt. This divided by ac is what? AC is v square by r. So this is the value of tan phi. Okay, so we got these two formulas. Okay, so here we got everything. We got direction of net acceleration, we got total acceleration, so we got everything. Okay, so this is how we can determine acceleration in case of circular motion. Okay, now this is one of the method of calculating acceleration in case of circular motion. There is another method which we can say that it is vector method to calculate the same acceleration in both the cases. Okay, but what is the use of that method? Because in sometimes in problems they will give you in terms of I cap and j cap, right? And that type of problems usually come in different competitive exams. So now we will see vector method. Okay, but to see before we move to this another method, let us discuss a very important concept of unit vector along radius as well as tangent. Okay. Tangent, in which case in circular motion. Okay. So, how to find out this? Let us try to make a circle with unit radius. So, let us assume that this is a circle of unit radius. Okay. What will be the unit vector? What will be the unit vector along radius? We can say that unit vector along radius or will be something like this or like this. Okay. Or so suppose this circle is this circle is present in the axis. These are the axes of this circle. Suppose these are the coordinate axes of this circle. Okay. Now we can say that this will be the unit vector. So if this is a unit vector, this is the point P. The magnitude of this is 1. So we can find out the coordinate of this point. The coordinate of this point is, suppose at this angle theta, the coordinate of this point we can determine by making it a right angle triangle. So how much is this length? How much is this length? This length will be equal to 1 sin theta, right? And how much will be this length? This length will be equal to 1 cos theta. So what are the coordinate of this point? What are the coordinate of this point? The coordinate of this point is equal to cos theta comma sin theta, right? So we can find out this unit vector. Okay, if I want to find out this unit vector, okay, so let us assume that the unit vector in this direction we can represent it as E r cap, right? So E r cap is what? E r cap is unit vector along radial direction. So what will be the value of E r cap? What will be the value of E r cap? This is E r. What will be the value of E r cap? The value of E r cap will be equal to cos theta I cap plus sin theta j cap, right? And where is tangential, where is unit vector along tangent? So this vector, we can say that this vector will be unit vector along tangent. So we can say that this vector is E t cap. Now our objective is to determine what is the value of E t cap. Okay. So how to find out the value of E t cap? Let us see. Now see, we have two vectors, one is E r cap and one is E t cap. We already have got what is E r cap, we need to determine E t cap. Okay. So suppose this is E r cap, right? And I have shifted the E t cap at origin only. So this value will be E t cap. We can have one more unit vector. How? See, if this is I cap and this is j cap, right? Then what is the direction of k cap? The direction of k cap is perpendicular to the plane and it is out of the plane, right? So there will be the direction of k cap. So here also the k cap will be in upward direction. Understood? You can assume that the k cap is out of the plane. Let us assume that this is k cap is out of the plane. Okay, this is k cap is out of the plane. So k cap will be out of the plane. You have to remember this. Okay, this k cap is out of the plane. Now, if I will try to find out, if I want to find out ET cap, how can I determine the value of ET cap, right? How can I determine the value of ET cap? So the value of ET cap, we can write it like this. ET cap can be written as C, k cap cross ER cap, k cap cross of ER cap, right? So k cap, suppose this is a pen, right? And this is the direction of ER cap, right? And we want to, and we will have another pen. This is the direction of k cap, right? K cap is over here, right? And we want to find out ET cap. So how we will do it? K cap cross ER cap, and this will be the direction of ET cap, right? Now let us substitute the value of ER cap. So this is ET cap. ET cap value can be written as k cap cross of ER cap is equals to cos theta I cap plus sin theta j cap. So what will be the value of this? This value k cross I, we know that it is equal to j. So this is equal to cos theta into j cap. What is k cross j? K cross j is equals to minus I cap. So this is equals to minus of sin theta j cap, sin theta I cap. Sin theta I cap. So what will be the value of ET cap? The value of ET cap can be written as minus of sin theta I cap plus cos theta j cap. Is this clear? So we have determined unit vector along radius as well as we have determined unit vector along tangent. Okay, now we have both the vectors, unit vector along tangent and unit vector along radius. Okay, is this clear? Okay, now let us try to determine how to find out acceleration in case of unit vector along radius, acceleration in terms of these unit vectors. Okay. Second method for calculating acceleration in circular motion. Okay. Now we will try to see the second method for calculating acceleration in case of circular motion. Okay. So let us make this circle, right? And we will have this as x-axis and this as y-axis. This is y-axis. Okay. So we can write the, suppose this is radius vector, right? The radius is r. So what will be the coordinate of this point? So coordinate of this point is r cos theta and r sin theta. Okay. So we have r cos theta and r sin theta. So this will be the vector r, right? So what we can write about vector r? So vector r can be written as r cos theta I cap plus r sin theta j cap, r sin theta j cap. Okay. We need to find out the acceleration. So what is acceleration? How do we determine acceleration? Acceleration is nothing, it is just equal to dv by dt, right? dv by dt, or we can say that it is double differentiation of r. So this we can also write it as double differentiation of r divided by dt, double differentiation of vector r divided by dt. Okay. So since we have the value of vector r, if we differentiate it twice, then we will be able to get the value of acceleration. So let us differentiate for first time. So what we can say here, the value of dr by dt, dr by dt, right? Since it is moving in a circle with constant radius, because it's a circular motion, so r will remain constant. So we can take out this r over here. What is the differentiation of cos theta? The differentiation of cos theta is equals to minus of sin theta, right? And since this is theta, so we have to differentiate theta also. So this is equal to d theta by dt, this into I cap plus the differentiation of sin theta is cos theta into d theta divided by dt, this into j cap, right? So what is the value of d theta by dt? This is nothing, it is just omega. This is nothing, it is just omega. So what we can write here, dr by dt is what? Dr by dt will be velocity vector. Okay, dr by dt is velocity vector. So this velocity vector will be equal to r into omega into minus of sin theta I cap plus of cos theta j cap. Is this clear? This is r into omega into minus of sin theta I cap plus cos theta j cap. Okay. So what is this vector? If you will try to look at this vector, what is this vector? This vector we have already seen. See, it is et cap, right? So what is this value? This velocity vector, we can write it like this also. This is r into omega into e t cap, right? This is velocity vector. What does it mean? It means if a particle is moving in the circle, and this is generally r cap. So at this movement, the particle is moving in this direction with the velocity vector of omega r, right? So we know that v is equals to omega r, v is equals to omega r. So we already know that v can be written as omega into r, right? Or omega can be written as v by r, right? So this velocity vector is nothing, it is just v, that is magnitude of velocity, into e t cap, right? E t cap is in which direction? E t cap is in this direction. Okay. So it is very much clear that this formula is giving both the information, magnitude as well as direction. Now we need to find out acceleration. Okay. So what is acceleration? Acceleration is nothing, it is just dv by dt. So what we have to do? We have to differentiate this quantity. Okay. What is the value of what will be the differentiation of this? So we can say we have to differentiate this quantity, right? So what will be the differentiation of this? V into et cap. So we can apply u into v method. Suppose if we have a function and you will have u into v form, that is in the multiplication form. So what will be the value of df by dt? df by dt, we will keep one function as constant and differentiate another function, dv by dt. then we will keep another function as constant and differentiate first function du by dt, right. Here also we will have two functions, one is v and another one is et. Okay. So, let us see this. So, first I will keep et as constant and differentiate v. So, this value will be equal to dv by dt, and now I will keep v as constant and then differentiate et cap. So, this value we can say that it is det cap divided by dt. What is the value of det cap divided by dt? Et cap we have already calculated that it is equal to minus of sine theta I cap plus cos theta j cap, right. You can see that this is et cap minus sine theta I cap plus cos theta j cap. Now, what will be the differentiation of this? This det cap divided by dt, this value can be written as minus of the differentiation of sine theta is equal to cos theta into d theta by dt, this I cap plus what is the differentiation of cos theta? The differentiation of cos theta is minus sine theta. So, this is equals to minus of sine theta into d theta by dt. This into j cap, right. So, what is this here? This we can say that minus of omega into cos theta I cap plus sine theta j cap. What is this cos theta I cap plus sine theta j cap? The cos theta I cap plus sine theta j cap is what? ER. ER cap. So, we can substitute this value. So, this value will be equal to minus of omega into E R cap, right. So, differentiation of unit vector along tangent will give you minus of omega into E R cap. Now, we can substitute this value. We can substitute this value in first equation. So, in this equation, which one? Here. You can substitute this value in this equation. So, what will happen here? This value A vector can be written as dv by dt into et cap plus, what is this answer? V into det cap divided by dt. So, this is the value of det cap divided by dt. So, we can write it like this. This is minus of omega into E R cap. So, what will be the value of this? This value we can further write as dv by dt into E t cap plus of v omega into minus of E R cap, right. So, we have already seen that this v omega can also be written as v square by r, and this can also be written as omega square into r. Okay. So, this will be the value of net acceleration, or we can say that this is total acceleration, right. So, as you can clearly see that this is et cap. So, what will be the magnitude of acceleration in tangential direction? So, this will be the magnitude of acceleration in tangential direction. So, we can say that this is nothing, it is just tangential acceleration, right. This is nothing, just tangential acceleration. And what will be the value of acceleration in radial direction. So, this we can say that v omega will be the radial acceleration. Okay. So, here we are getting again both the information, that is a radial as well as a tangential. Okay. So, these are the two methods that can be used to find out acceleration in case of uniform circular motion or a non-uniform circular motion. Okay. Let us try to see one very easy example so that this concept will be solidified. Suppose if a particle is moving in a circle, right, and particle starts from this point, right. The initial velocity of the particle is 5 meter per second. This is the initial velocity of the particle, right, and acceleration of the particle, tangential acceleration of the particle is 2 meter per second square. So, tangential acceleration of the particle is 2 meter per second square. Okay. The radius is equals to 1 meter. Here the question we can ask is find out acceleration at different point. First at t equal to 0, okay, and the second at t equal to 1 second. Okay. Now, so let us try to see this, how to solve this question. See, so at t equal to 0, the velocity of the particle is 5 meter per second. This is the first case. So, at t equal to 0, the velocity of the particle is 5 meter per second, right. So, what will be the value of radial acceleration or tangential acceleration? The radial acceleration value will be equal to what? V square by r. So, V is 5. So, this we can say that it is 5 square divided by r is 1. So, this value will be equal to 25 meter per second square. Okay. So, 25 meter per second square. So, this will be the value of radial acceleration, that is 25 meter per second square. And what is the value of tangential acceleration? The tangential acceleration will be in upward direction, that is also equal to 2 meter per second square. Okay, this is 2 meter per second square. So, what will be the value of net acceleration? The value of net acceleration is equal to 25 square plus 2 square whole root, right. This you can calculate and find and state that the net acceleration will be equal to this. What is the direction of net acceleration? The direction of net acceleration we can also determine is in this direction. This will be the direction of net acceleration. Okay. So, this is the first case. Now, how to find out acceleration at t equal to 1 second? So, at t equal to 1 second, we need to find out the speed. So, what will be the speed? We can say that if the initial speed is 5 meter per second, so we can use v is equals to u plus at. So, v is equals to u is 5 plus tangential acceleration is what? 2 meter per second square. So, 2 into t is 1. So, the velocity at t equal to 1 second will be 7 meter per second. Okay. Now, what will be the total acceleration? So, the total acceleration at t equal to 1 second, it will again have two components. One component is towards the center, that is the radial acceleration, and one component is towards the tangent. This is already given. This is tangential acceleration. So, tangential acceleration is already given, that is equal to 2 meter per second square, right. What is the value of radial acceleration? The value of radial acceleration will be equal to v square divided by r. Okay, so v is 7, so 7 square is 49 divided by 1, or we can say that 49 meter per second square. Is this clear? 49 meter per second square. What is the value of net acceleration? The value of net acceleration is a r square plus a t square whole under root, and this value will be equals to 49 whole square plus 2 square whole under root. Okay, this you can calculate, and that will be the value of net acceleration. Okay, so I hope with this example and by these two methods, I hope the acceleration in circular motion is clear to all of you. So that's it for today. Thank you.